Diba? Sabi ba?
Sige, sige. Lakyan mo. Lakyan mo. Tasan mo to, habang. Yan.
Tasin nyo na yung dingding sa tubig.
Ako, nilipis. Kasi mainit naman.
Each region may be connected to this dynamic ecosystem through natural, technological, biological, environmental, and/or link hazards or consequences. Infrastructures and environmental sensitivity in many nations exhibit patterns of loss and damage depending on the degree of resilience measures implemented and the socio-economic situation of those nations. Risk management, as it relates to disaster risk, refers to a system, community, or society's capacity to withstand, absorb, accommodate, adapt, change, and recover from a hazard in a timely and effective manner, including the preservation and restoration of its crucial structures and functions. In addition to building sturdy infrastructures, engineers may be crucial in disaster response activities. To help first responders coordinate their efforts, engineers can work with them to design and implement communications systems as well.
Resilience is about anticipating, planning, and reducing disaster risk or effectively protect people, communities, and nations as well as their livelihood, health, cultural heritage, socioeconomic assets, and ecosystems. The concept of bounce back and spring forward and build back better are often used in the context of resilience. Furthermore, disaster resilience has become a systematic challenge for humanity, and finally, disaster response has been integrated into the basic framework of all related governance as natural resources are exploited and used to abuse Mother Earth. However, with the development of deadly infectious disease epidemics, acts of terrorism, social unrest, and stock market fluctuations leading to financial disaster in recent times, it is more necessary than ever.
Moreover, disaster mitigation is the reduction of suffering experienced by affected individuals after a natural disaster. Civil engineers provide humanitarian and commercial disaster relief by building new shelters or rebuilding damaged shelters to house people displaced by disasters, while developing and streamlining logistics strategies for reducing the lack of food and water in the affected communities. They face the lack of or damage the communication system caused by the natural disaster. They prevent the spread of infectious disease by ensuring the sanitation system, such as sewage and water plants remaining functional and accessible to disaster victims.
They facilitate evacuation routes with constructed transportation equipment to transport individuals to safer, cleaner location, and they begin to rebuild failed dams and levees by using knowledge gained from failure and preventing similar disasters in the future. As a result, civil engineers will continue to play an important role in mitigating the effects of potential disaster by focusing on developing innovative designs and methods based on in-depth studies of structural issues and the environment and ethically during and after natural disasters.
By carefully analyzing the expensive effects of all types of natural disasters, engineers continue to develop integrated prevention management and procedures through concentrating on creating updated designs and procedures based on in-depth analysis of structural, environmental, and social problems before and after natural disasters. They continue to be essential to reducing the effects of possible disasters. One of the most crucial ways engineers can help communities prepared for disasters is by designing infrastructures that can endure severe weather, construction regulations that require that homes and other structure be designed to survive severe winds and earthquakes, as well as infrastructure components like bridges and highways that are made to withstand flooding and other natural disasters.
In addition to building sturdy infrastructure, engineers may be crucial in disaster response activities. To help first responders coordinate their efforts, engineers can work with them to design and implement communication systems as well as preparations for community evacuation in the event of a catastrophe. The utilization of technology is a crucial component of engineering for disaster resilience and emergency response. So, for example, engineers can develop sensors and other monitoring systems that might be instantly notify people of earthquakes, hurricanes, and other natural disasters and allow for prompt planning. Using advanced modeling and simulation technology, engineers can also predict how natural catastrophes will affect communities and develop plans for minimizing damage and managing crises.
It's admirable to have the ability to be resilient. It aids in managing and coping with difficulty. It empowers you to take advantage of your circumstances. One must be careful not to allow their resilience to serve as an excuse for bad behavior. In addition to saving lives and protecting property, well thought out emergency preparedness and response strategies frequently can help resilience and post-disasters recovery by reducing the impact of a disaster.
Engineering may be extremely important in creating catastrophe resilience. Early engineering inputs should be incorporated into land use planning, making risk identification and mitigation a crucial part of the entire procedure. The government should be aware of the need to invest in resilience for sustainable city given the economic impact of disasters.
Maintaining and gaining public trust is crucial while responding to natural disaster and other emergency situations. This is due to the fact that during reaction events, communication are frequently directed toward saving lives, preventing an emergency from getting worse, and providing needed services. Some community members are occasionally feel that what is being asked of them in support of the response has an influence on their liberties or human rights. Public trust in government leaders' communication is crucial to upholding peace and order and providing for the needs of the many during these situations. Communication in reactions situation benefits from being risk-aware, apolitical, and centered on community health and wellness. Processes leading to reconstruction and resettlements during the recovery phase would take up to 10 years. Question number 1. How can engineering help make emergency response and catastrophe resilience better? The answer is engineering can play a crucial role in improving emergency response and catastrophe. 1. Developing advanced technologies and systems. Energies can design and develop advanced technologies and systems that can help emergency responders to quickly and efficiently respond to disaster. For example, communication system, mapping tools, and networks can help emergency responders to get real-time information about the situation on the ground. 2. Infrastructure. Engineers can design and build resilience infrastructure that can withstand natural disasters and earthquakes, hurricanes, and floods. For example, building can be designed with earthquake resistance features and flood control structure and can be designed or mitigate damage. 3. Risk assessments. Engineers can conduct risk assessment to identify potential hazard and vulnerabilities and immunities in structure. Can help emergency responders and local affected disaster preparedness plans. 4. Developing sustainable solutions. Engineers can develop sustainable solutions that can community to recover from disaster and build renewable energy system that can provide power during disaster, or develop sustainable water management system that can help community with droughts and can help to make emergency response and catastrophe resilience better by developing advanced technologies, building resilient infrastructure, conducting risk assessment, and developing sustainable solutions. Okay, for the question number 2, what fundamental engineering concept must be taken into account while threatening structures that are resilient to disasters? When creating structures that are resilient to disaster, there are several fundamental engineering concepts that must be taken into account. Some of these concepts include, this is the 6 of the answer. Structural analysis. Structural analysis is the process of predicting the behavior of structures under different loading conditions. It is important to analyze the structure to ensure it can withstand the forces that it may experience during a disaster. 2. Material selection. The selection of materials is critical in creating structures that are resilient to disaster. Materials must be strong, durable, and able to withstand various forces and stresses. For example, concrete and steel are commonly used material for building structures that are resilient to disasters. 3. Design codes and standards. Design codes and standards provide guidelines for designing structures that can withstand disasters. These codes ensure that structures are designed to withstand the force they are likely to experience during a disaster. 4. Redundancy. Redundancy involves providing multiple systems or components that can perform the same function. In the event of a failure, redundancy ensures that the structure can continue to operate. 5. Damping. Damping is the ability of structure to absorb and dissipate energy. Structures that are resilient to disaster should have damping system in place to reduce the effect of vibration and other forces to structure. 6. Modularity involves designing structures in a way that allow for easy replacement or repair of damaged components. This approach ensures that the structure can be quickly repaired or reconstructed in the event of disaster. Overall, when creating structures that are resilient to disaster, engineers must consider structural analysis, material selections, design codes and standards, redundancy, damping, and modularity. These concepts can help to ensure that the structure can withstand various forces and stress and can be quickly repaired or reconstructed in the event of disaster.
The way they daddy spin, they gon' need something. Do you love me, baby? I know you love me, baby. Yeah, I cheated on you, can you trust me, baby? Have 2 kids with me, now you stuck with me, baby.
I've been searching for this all my